Okay, welcome to the last section in chapter 3, antiderivatives. Okay, antiderivatives is the opposite of derivative. So derivative of x squared is 2x. So now we're going to take 2x and get back to x squared, okay? Back to x squared. The notation's important here. The notation important. So it says find the antiderivative of f of x equals x, and the antiderivative is always the capital F, okay, capital F. So the original function is capital F, okay, and the derivative is f of x. That's how they do it. It's kind of weird, but once we get to integrations, that won't matter. That's in chapter 4. Here we're just practicing how to do the antiderivative. So here's how you do the antiderivative. Okay, so this is x to the first power. So you're going to take that power, increase it by 1. Then you're going to divide by that power. Okay, and that's the derivative. Now, problem is, could there have been a constant? Like, could it have been 1/2 x squared plus 7? 1/2 x squared plus 2? We don't know. So if it's called the indefinite, we don't know, you have to add a plus c when you take the antiderivative. There must be a plus c. And again, here's an illustration of it. Look, all of these functions have the same derivative, x squared. So how do we know which one it was? Well, you write plus c. And then we can find c given certain parameters. You'll see that in a little bit, okay? So, the functions, when they're polynomials, super easy. All you do is you take the function, take the power, increase it, divide by that. Now again, I typically write it as 1/2 x squared plus c, but the rule is to divide in case there's a coefficient there. You don't forget to divide it. It's however you want to see it. Now, as before, I would need you guys to make flashcards of these, okay? Make flashcards of those and figure out the antiderivative. So derivative of sine is cosine, so cosine's antiderivative is sine. Sine's antiderivative is negative cosine because cosine's derivative is negative sine. So you will have to memorize those there. Those are the most famous ones. Again, when you do this, so there are different methods. Memorizing is the easiest. Use flashcards. So here we have 2 sine negative 2 over square root of x. So I like to write this as 2 sine x minus 2x to the negative 1/2. That'll be much easier. So again, derivative of sine is negative cosine. The 2 will just drop, or the antiderivative, excuse me, of sine is negative cosine. So it's going to be negative 2 cosine x. That takes care of that. Okay? And then minus 2. So again, we need to increase this by 1. So it's going to be, the negative 2 stays the same. And we're going to increase x by 1. So that's plus 2 over 2. So that's 1/2. Now you have to divide by 1/2. And here's the funky part. Okay? So I'm going to write divide by 1/2. But if you divide by 1/2, it's like multiplying by 2. So you're going to get negative 2 cosine x minus 4x to the 1/2. And then don't forget to add plus c. Have to have plus c, okay? And again, you would say, well, when you took the derivative, you should have plus c there. Well, plus c is still c, because c is a constant. So if this was 5, that was 7. 7 plus 5 is 12. 12 is still a constant. You put plus c, it won't matter. Okay? It won't matter. All right, so this says find f if f double prime is that, f of 0 is 3, f prime of 0 is 4. So again, this one's a little difficult. So first thing you want to do is find f prime. We're going to take sines. Antiderivative is negative cosine. And cosine's antiderivative is sine. Okay? And plus c. So we need to find c. Why? Because we're going to take the antiderivative. So to find c, we need the f prime. So f prime of 0 is 4. So that's 4. Okay? Minus cosine of 0 plus sine of 0 plus c. cosine of 0, again, we're in the unit circle, we're right here. That point is 1, 0. So it's going to be 4 equals negative 1 plus 0 plus c. So c is 5. Okay? So now we have f prime equal to negative cosine x plus sine x plus 5. So now we want to find f double prime. Okay, so f double prime, again, or not f double prime, I'm sorry. We want to find f, so we're going from f prime to f. And again, we have antiderivative of cosine and sine. Antiderivative of cosine is sine is negative cosine. So this is going to turn out to be equal to negative sine x, because antiderivative of cosine is sine, drop your negative down, plus antiderivative is negative cosine, and plus 5x. And again, divided by 1, I don't usually write that, and then don't forget your plus c. And we're going to use this fact right here, f of 0 is 3, so we're going to have 3 equals negative sine 0 plus, actually I'll just write minus, might be easier, minus cosine of 0 plus 5 of 0 plus c. Okay? So you're going to get 3 equals, sine of 0 is 0, 1 plus 0 plus c. So add, you're going to get 4 equals c. And so your grand final answer is f of x equal to negative sine x minus cosine x plus 5x plus 4. All right? So in the grand scheme of things, there's that. Okay. So last but not least, we have acceleration is the leads to the derivative of the velocity. So if I tell you the acceleration, you can find the velocity by taking the antiderivative. So you're going to get t to the second power, 3 over 2 minus 2t. We're going to plug in 10 for v of 0. So we have plus c there. Find our c, so you're going to get 10 equals 3 halves times 0 squared minus 2 times 0 plus c. So c equals 10. Okay? So this is 10. Then we want to find the position function, so take the derivative, antiderivative again. So you're going to get, okay? So now we have to find c. Again, they tell me s of 0 equals 1. So that's s of t. So s of 0, so is 1. So 1 equals, that's just going to be 0. Okay? That's going to be 0 plus c. So c equals 1. So our final answer, and again, I'll simplify this, is going to be s of t is 3 over 6, which is 1 half, t cubed minus 2's cancel, t squared plus 10t plus 1. And that's how you do the antiderivatives.